Okay, so Newton's second law, law of gravitational attraction. What is it? Um, Newton, after he published his three laws of motion, he also postulated another law that governs the mutual attraction between any two particles. Okay, so uh, let's say we have a particle, we have another particle, we have another particle, another particle. These four particles exert a mutual attraction to any other particle, to every other particle, because the law of gravitational attraction states that every particle of matter in the universe attracts every other particle in the universe with a force that is proportional to the product of the masses of these two particles and inversely proportional to the square of the distance. So mathematically we can write that statement as m1 times m2 divided by the square of the distance. So we can finalize this equation by introducing a constant. And this is the force of attraction between any two particles. This is the gravitational force of attraction, where F is called the force of attraction, the G is called the gravitational universal constant of gravitation, and has a value of 66.73 times 10 to the negative 12 meter raised to 3 kilogram per second squared. And of course, m1 and m2 are the masses, the mass of each particle, and the r is the distance between two mass centers. Gravitational force always acts along the line that joins the two particles, and they always form an action-reaction pair. So let's consider these two particles here. Let's call this m1 and let's call this m2. The force is acting on either of the two, and of course it is equal even if they have different masses. This is Fg, this is also Fg, and it is mutual even if m1 is not equals to m2, and of course the distance is this. This law is universal. It means it acts in fundamentally the same way between the sun and the earth, between the earth and your body, between a planet and one of its moons. Meaning, as long as you have a mass, it acts on you. This is the concept of universal law of gravitational attraction. So if we consider the Earth and all the particles or all the bodies that are located or near at the surface of the Earth, we can consider this. We can solve what is the attraction between the mass of the Earth and the mass of the objects that are located near or at the surface of the Earth by using this equation, of course. And if we substitute the mass of the Earth, let's call it the ME, and let's say the just M, mass of any object, and the distance, the radial distance, the radius of the Earth, if we plug in them on these equations, the distance, the radial distance of the Earth, the mass of the Earth, the mass of any object, this will result to, or this will reduce to, weight is equals to mg, because the mass of the earth, the radius of the earth, and the universal constant of gravitation will be equal to the gravitational attraction, which is g. This is 9.81 meter per second squared in SI system. And this Fg is now called the weight. So weight is just a special term for a force that is located near the surface of the earth, and it is the only force, it is the only gravitational force that has any sizable effect or a sizable magnitude that can be found near or at the surface of the earth. Okay, so if you think about it, every other person is attracted to every other person on the earth, but they are not clumping together. Why is that? It is because the attraction, the mutual attraction, oops, it's not writing, the mutual attraction between you and somebody else is not enough to, to clump you together. It's because the static friction force is way stronger than the gravitational force of attraction. You can actually verify this one, no? You can verify this one. You can check this out, because Fg in this case is very, very small. You can solve, you can plug 66.73 times 10 to the negative 12. Let's say you have a mass of 55 kilogram and the other person has a mass of 50 kilogram, and the distance between you is just a 0.5 meter, and of course you plug in 66.73 times 10 to the negative 12. This value is very, very small because of this magnitude. But the fact that that force, that mutual force exists between you, no, it's not just enough, because the static friction force is way bigger than the mutual gravitational attraction between any particles near or located near at the surface of the earth. So for a metric system, we have a value of g that is 9.81 meter per second squared, which is weight equals to mass times g. For a 1 kilogram of mass and a value of 9.81 meter per second squared, you have a weight of 9.81 Newton. For FPS or English system, the value of G is 32.2 feet per second squared. And for a mass of 1 slug times 32.2 feet per second squared, we have a force of 32.2 pound. So that's the difference between the metric and the English system. The mass is kilogram in metric. In English it's called slug because of the word sluggish.